Hello everyone. Once again, this is KP the Math G. And so I am very delighted to be here to discuss with you some more calculus. This time we're talking about the definition of the derivative. And we have already looked at this before in a prior lesson. We have looked at limit. The limit as h approaches 0. F at x plus h minus f at x all over h. And I think in our last lesson we identified that with maybe when we talked about the slope of the tangent line, or when we talked about a little bit about the about instantaneous velocity. So we did touch on that. And so we want to look at this expression here. This equation is f at x is 3x squared minus 10x plus 5. We want to find f prime at x. And what that means is the prime just simply means I'm finding the derivative. Keep in mind, everyone, that when you are finding the derivative of anything, you're looking for a rate of change, feet per second, miles per hour, and so on. And then if you took a second derivative of feet per second, you would get feet per second, which is feet per second squared. That would be acceleration. And so we would take a second derivative there, and we're going to get into those later on, but at least for right now, what we want to do is we want to use this definition here to see what the derivative of this is. Okay, so let's get busy here. So let's see here. Remember now, the first part of this is x plus h, and it's going to go in each one of these x's, here and here. So at the very first, we're going to have 3, the limit, as h approaches 0. Don't ever forget that part of it when you're taking a test or doing an open response problem. Just don't forget that. Okay, so 3 times, now we're going to say x plus h, and we're going to square that, okay, minus 10 times x plus h, and then plus 5. Whoa, and we're going to need to erase already. Okay. Alright, so there we go. Let's just move that out of the way. And then we're going to do now minus. Now f at x. I like to do this right here. Remember, all of this is over h. Don't forget that h in there. Sometimes I do. Just the function of f. Well, it's just 3x squared minus 10x plus 5. And like that. Okay. Now remember, calculus students know not to multiply 3 by this first. You square this first. Okay, and so if you square this, the first term is squared, and so is the last term, but the middle term is x times h, so plus x times h, and you're going to multiply that by 2, because you have 2 of these. Alright, x plus h, or x times h times x, you've got 2 of them. Alright, 2xh. Remember, multiplication is commutative, so you can do that. So now plus h squared. Okay, that takes care of that part of it. We're going to distribute this 10, this minus 10, so minus 10x minus 10h plus 5, by the way. Whew, there's a lot here. So let's see, minus. Now we're going to distribute this minus, and with all 3 of these terms, so this is going to be minus 3x squared minus a negative is plus 10x, and then minus a positive is minus 5, and all over h. Wow, that's a lot already, isn't it? Alright, now we have to distribute this. And just think, once we do this and we start, there is a shorter way to do this, and it's going to be a much shorter way. And you're going to say, good gracious, KP to the math G, why didn't we just do it that way? Well, we're applying the definition is what we're doing in this case. Alright, so here we go. 3 times x squared is 3x squared. 3 times 2 is 6, xh. 3 times h squared is 3h squared, minus 10x, minus 10h, okay, plus 5, okay, minus 3x squared, plus 10x, minus 5, all over h. This is lengthy, isn't it? Well, we have some things that we can add out or subtract out. 3x squared minus 3x squared is 0. Minus 10x plus 10x is 0. Plus 5 minus 5 is 0. We should be able to eliminate these, this alpha at x altogether. So now it does start to get a little bit smaller now. Okay. So now we've got 6xh plus 3h squared. Let's see, minus 10h. Okay. Making sure I've got all my terms. 1, 2, 3. It looks like that's everything now over h. Double check. 1, 2, 3. No, 1, 2. That's it right here. So 1, 2, 3. That's it. Alright, well, we're going to go on down. Hopefully we won't have to flip this over, but I'm betting we will. Let's put that down correctly here. Limit. The limit as h approaches 0. Well, let's see what we're doing here. We have an h in each term, so we can factor out a common h. So h times 6x plus 3h minus 10. Alright, now over h. Boy oh boy, the h's cancel out. And look right here, I got h being 0. So let's flip this over. Let me write this down so that I'll know what I have. Because when I flip it over, I'm likely to forget. So let's see here. Right now we have the limit as h approaches 0. 6x plus 3h minus 10. Okay, there it is. Alright, and so let's do that now. Flip it over. Let's get our eraser. Alright, here we go. That's it. Okay, that should do it. Now let's put our eraser right here. Before we go any further, I'll show you a picture of me and my grandson. Now, you have to understand this picture. I am wrestling with this boy, actually. And you can see the grimace on my face, just to know, hey, he was actually wrestling with this young boy. Now, a little 2-year-old here, he is stout. So he was trying to wiggle his way down. I happened to get him in position for the picture just before the camera went off. We had 10 seconds to do this, and at the very last second, that's what the camera gave us. So There it is right here, just a little close up there. There you go. That's my little grandson Levi. And so I'm happy that he's something else, but he is my good grandson, I tell you. I love him. Okay, so let's finish our problem. Sometimes I want to get off and do something like that. Here we go. We've got the limit then as h approaches 0. This is looking really good now. 6x plus 3h minus 10. And then if h is 0, now we say the limit as h approaches 0, 6x plus 3 times 0 minus 10, which is now the limit. As h approaches 0, this is gone, so now we're just left at 6x minus 10. And that's all we can do. This could represent the slope of a tangent line. This could represent instantaneous velocity, and that if we wanted to make this x be t at 2 seconds, t at 2, 6 times 2 is 12, 12 minus 10 is 2. Okay, 2 feet per second. You see what I mean? Okay. All right. So anyway, that's what it could be. So that could represent a lot of things: miles per hour, feet per second, meters per second, and so on. So anyway, let's take a look at this now. Let's find, speaking of the tangent line, so let's do this. Let's find the slope of the tangent line. Let's put that B in there. Tangent line. T. Okay, at, and you could just say x equals 2 because that's all you really need, but we'll just say at 2, negative 3. Okay, x is 2, y is negative 3. Okay, so let's see. All you have to do now, this is the slope. This represents the slope of the tangent line. Tangent line, okay. So all we have to do is, this is f prime at x, which is 6x minus 10. So then f prime at 2. So 6 times 2. How about that? I didn't even think about plugging that in earlier, believe it or not. That's 12 minus 10, which is equals 2. Again, this is the slope. So m is equal to 2. If you wanted to write out an equation, you have, this is x1, y1. So in this case, we could say, if we want to extend that and say, well, what's the equation of the line? Now that you have the slope, now that you have x1 and y1, you have y minus y1 equals m times x minus x1. We could quickly just put that in there. Y minus negative 3 equals m, which is 2, times x minus x1, which is 2. Okay, y plus 3 minus a negative is plus, so we're going to subtract 3 from both sides. And if you wanted to, you got y is equal to 2 times x minus 2 minus 3. Alright, and there it is. You can do that fairly quickly. If you wanted to find the equation of the tangent line to some curve, that curve happens to be at 3x squared minus 10x plus 5, what we originated with. Okay, passing through negative 2 comma, 2 comma negative 3, and all we had to do was find the slope. So we had to find that limit first of all. To get the derivative, we use that limit to do that. Okay. So that's how you do that. Also, there's another thing we want to look at. Let's keep this in mind here. There's so many applications that we could do. We already looked at 2 of them right here. We found the slope. We also found, we found the derivative, 6x minus 10. We found the slope, and then, or at x equals 2. And then we found an equation of the tangent line. So in this case now, since this represents the slope of the tangent line, we want to also find the slope, which represents the slope of the horizontal tangent. Now, of course, we were dealing with this equation here, y was equal to, and I don't want to get into this too much, 3x squared minus 10x plus 5. What that simply means is this is going to be somewhere, I don't know where it's going to be, but it's going to be somewhere on this xy coordinate plane, and it's, we do know by the fact that it is positive, if you know anything about a quadratic, that if the lead coefficient is positive, that the cup is going to cup upward, or we say in calculus, concave upward. Now, where it's going to be, I don't really know that. We're just going to put it somewhere, and for right now, we will put it somewhere like this. I have no idea where it is. It could be somewhere over here. We're not worried about that at this point. But when we talk about the horizontal tangent line, well, there are several tangent lines to this curve. Okay, so what we're talking about here, well, here's a tangent line right here, but that's not the horizontal one. And there's a point there, there's a line there, and then there's one over here. Okay, and it's right, it does like that, doesn't it? And there's one over here on this side. These are negative slopes. Okay, these are positive slopes on this side. Okay, like this, like this. Oops. Okay, it needs to be on the line itself, like that. There we go, a little better. But the horizontal one is the one that goes across this way, and so we want this to be right here. And I could have went through the trouble of finding out exactly where this is, but again, for our purposes, we don't really need to know that. We want this line to go right through here. This is the vertex of this. It's called the lowest point of the graph. Right? It's the actual minimum. Okay, so so we have the minimum of this graph here, wherever that is. We're going to find out in just a moment here. So the slope is already right here. So this m of any horizontal line is always 0. The slope is always 0. So since this is the slope of this tangent line, and this is a tangent line, by the way, then what we want here is we want 6x minus 10 to be equal to 0, don't we? Okay. Alright, so we want it to be equal to 0. So let's see, we want this, so let's see, we want the point is what we're looking for. So 6x is equal to 10, and when we divide by 6, we have x is equal to 10 over 6. If we reduce that in the lowest terms, that's going to be, what, 2 goes into 10 5 times, 2 goes into 6 3 times, so 5/3. Okay, and then we could plug this back in to the original problem and we could figure out what the y value is. So here's y right here. We could figure out what the y value is. So we know that this line right here is, well, okay, we know that that is that x is equal to 5/3, all right, and then we just wanted to find the y value. Okay, all right, so we could do that, but let's see, if we did do that, this would be a lot of arithmetic involved here. Let's see, this would be okay, so 3, let's see, and of course this would work, by the way. This is actually looking at the x value is 5/3, okay, which is actually what, 1 2/3, something like that. And then we're going to find the y value if you want to find that. Okay, so we do know the x value of this vertex right here, where this line crosses right here. Okay, this is the part of the vertex. We need the y value, so we could find the y value just by plugging this in. So 3 times 5/3 squared minus 10 times 5/3, and then plus 5. Okay, so let's see, if we're careful we can get this. We can't cancel this out, divide this out, because we got to square this first. So 3 times 25 over 9 minus 10, well, let's move 10 over 1. 10 times 5 is 50 over 3 plus 5. Now what we can do is we can get a common denominator, but this 3 will divide out with the 9. 3 goes into 3 one time, 3 goes into 9 3 times. So what we have here is y is equal to 25 over 3 minus 50 over 3 plus 5. And we can at least figure these two out first if we want to. So let's see, 25 minus 50 is a negative 25 over 3 and then plus 5. So let's see, 5 can be written as something over 3. So 5 over 1. We multiply by 3, we get 15 over 3. 15 over 3. And now y is equal to negative 10 over 3. Negative 10 over 3. Wow, I mean, I didn't know where to draw this, but evidently the x is positive and the y is negative, if nothing else. So I got lucky. I could have put it over here, I could have put it up here, I could have put it up here, in any of the other quadrants, but so happens that this is where it is. So if you want to be a little more, want to write this out a little better, maybe, I don't know, but once you get this, you're done. You don't have to really do this anymore. 1 times 3 is 3 plus 2 more. Okay, see, 3 times 3 is 9, so 3 and 3 times 3 is 9 and 1, 3 times 3, and then 1 more is 10. So really this point right here is 1 2/3, which it should be moved over and down maybe a little bit further. So anyway, this is not drawn to scale. This is 1 2/3. What are you talking about? This point right here is 1 2/3, and this point down here is negative 10/3. So, all right, so that's the y value right here, is negative 10/3. Okay, so anyway, okay, not drawing the scale. Haha. Anyway, that's it right there. If you want to do that, I'd leave it like this right here if you wanted to find the point. Okay, that's what we're talking about here. Sometimes you just ask to find the x value, so all you have to do here is just simply say, hey, x is equal to 5/3, you need not to find the y value unless they ask to find both of them. Okay, so that is all we have for that one. Okay, that particular problem. And there's more applications that we could use if this, again, if we wanted to say, anyway, that's the idea behind it. Okay. All right, so let's see here. Let's do another problem. I want to do one more, and then we will close the lesson. Okay. All right. So, and this may take a little while to do because it is a little difficult to do. This one's more straightforward. And later on you'll find that this derivative is very easy to find, which I'm not going to do just yet. I want to kind of leave that hanging for right now. Okay. Alright, here we go. Let's erase all of this. I wish I just had one of them big, huge magic erasers. I can just pull the thing forward and back and then it'll erase everything. I don't have any such, but at least I have a good board and I'm thankful for it. My wife got this for my birthday, actually. My 63rd birthday. That's what I want. I want a board so I can use that to teach do YouTube videos. Calculus. Okay. And maybe other courses as well, not just calculus. Okay, one more, and then we'll bring our lesson to a close. Okay, so let's see. Let's given that f at x. Okay. F at x is equal to the square root of x. Wow. And if we're going to use that limit, we want to find f prime at x. Of course, now we have that limit as h approaches 0. Alright, remember it is x plus h, that's L at x plus h, minus L at x over h. So we're going to put x plus h right here. So the limit as h approaches 0. Alright, so the square root of x plus h minus the square root of x over h. Wow. Whew. Okay. What we find here is that what we can do to kind of help this situation out is we can multiply by the conjugate of this. We call it a conjugate. The conjugate of a minus b is a plus b, and vice versa. This is called a conjugate. So in other words, a minus b, a plus b. Alright, and of course if we do that in the numerator, we have to throw that down here in the denominator as well. And the reason we have to do that is if we plug 0 into h right now, we have the square root of x minus the square root of x, which is 0, and then 0 here, 0 over 0. So we got to do a little something different and not just have 0 over 0. So this is what we do here. Well, let's see. Let's multiply this thing out. Wow. Now let's kind of keep in mind that the square root of c times the square root of c is just c. It's the square root of c squared, which is just c. So what we have here is the limit. As h approaches 0, this times this is just x plus h. And then of course if we multiply this out, we see that this is going to be the square root of x plus h times the square root of x, and then the square root of x plus h again times the square root of x, and one is minus and the other one's plus, and they will cancel each other out. This one just does this way. You just do the first times the first and the last times the last, and a minus times a positive is a negative. Okay, square root of x times square root of x is just x. Don't fret over it. That's it. That's all you have to look at right there. Oh, but we almost forgot something here. H times the square root of x plus h plus the square root of x. Wow, we didn't need to forget that. Oh my goodness. Okay. I'm not going to blame it that I'm 63 rather, so I'm not 65 yet. That I forget so easily. The limit as h approaches 0. Here we go. What is this?